Okay, we're going to look at the first part of the practice multiple choice. So it'll be broken up in probably 3 videos, so this is just the first one. Okay, so on this first item, we have to figure out what the equation is of the graph. Now you should recognize that this parent graph is 1 over x, but that part's already pretty much given to you because those are all of our choices. I should realize that this has been shifted to the right 3 and down 2. So right 3, down 2. And it's flipped. So remember, when I do shifts left and right, we do the opposite. So I'll have to use x minus 3. The down 2 is minus 2. Flipping it over gives me a negative. So this causes it to flip. This causes it to shift to the right 2, right 3. And this causes it to shift down 2. Okay, let's look at the inverse. So when you're working with an inverse, this is like having y equals. I'm going to exchange x and y. So I have x equals 4 plus the square root of 2x minus 1. Change that to a y. Okay, and I'm going to solve for y. So I got x minus 4 equals the square root of 2y minus 1. Then do the square root. I'm going to square both sides. Then we add 1. And finally, we're going to divide by 2. So I get y is equal to x minus 4 squared plus 1 all over 2. This is what H inverse is. So, which is pretty much just rewriting the same equation again. We just have to identify which one it is. In this case, it was C. Okay, this one takes a little more thinking because you got to think about how the different parts are going to go together. So we've got log base b of square root of 1/2. We want to look at all the different possible forms. So when I see this one, a couple things I can do. I'm going to use my rules of exponents to kind of try to rewrite this. Well, one thing I could have is log base b of 1/2 raised to the 1/2, and I can bring the 1/2 out in front. So that's one of the possibilities. If I actually want to rewrite this as in terms of base of 2, this one right here is equal to log base b of 2 to the negative 1, and then we took the square root. So this one could be rewritten as log base b of 2 to the negative 1/2. Then I can move the negative 1/2 out in front, and that gives you this answer. So we're looking at ways to manipulate it. Now when you see something that says all expressions that are equivalent, you want to look for at least 2. Sometimes there may only be 1, but try to think mostly on 2s. Sometimes there could be even more. Okay. Onto our inequalities. So when I look at the graph right here, and I notice the first ones are the 2 to the x's, so I'm going to start with it. If you're looking for the parent graph for 2 to the x, you look for the shift up and down first. This is down 2. So that's the first thing I'm going to look at. And I think on your guys' problem, I think they had this one was 2 to the x minus 3 minus like this. Okay. I had an earlier version. Okay, so I know it's down 2. So I'm able to eliminate a couple of the other ones. At least eliminate that one. Okay, now I want to see where my shifts left and right are. I look for where it's 1 unit above. So this is down 2, and it's to the left going over. It goes right here. Here's our axis, left 3. Okay, so again, shifts left and right. We do the opposite, so it's going to be 2 to the x plus 3, then down 2, so it's going to be one of these two. Now look at where the shading is. The shading is below the graph. This is the above side, that's below. So that means it's going to be B. Now I look at my parabola. The vertex is at -4, +3. So again, right here, we are going to be left 4 and up 3. So again, we do the opposites but shift left and right, and it's flipped. Well, both the equations happen to match it. Now I'm just thinking about the shading. The shading, if you notice, below it would be in here. It's actually above, and it looks kind of a little bit sneaky, but it is in fact above. Okay, let's look at question number 5. Okay, so we're going to try to find a solution to this equation. So I'm going to have to use my log properties. The first log property I'm going to use, and to kind of reminder of our log properties, and I'm just not going to bother writing the base on these. Log of A plus log of B is equal to log of A times B. Log of A minus log of B is equal to log of A over B. And the reason why these work, just to give a quick little review. Logs are exponents. When we multiply quantities, we add the exponents. I'm adding my exponents here. When I divide quantities, I subtract exponents. Then when we raise an exponent to a power, for example, if I have log of A to the x, this is equal to x log of A. And I can go either direction. So this last one is probably the most important one. That's the one we use typically for solving. Okay, so let's take a look at actually this problem right here. Well, we have a sum. I need to be able to put these together. So I'm going to rewrite that as log base 2 of x times x plus 4. And I'm going to apply this rule by going the opposite direction. I'm going to take the 2 and then move it up to top, because this way they're all log base 2. So log base 2 of x plus 1 squared. Now since I have log base 2 equaling log base 2, I can drop the logs. We have x squared plus 4x is equal to, now I need to expand this out. So be careful when you have to do x plus 1 squared. If you need to do x plus 1 times x plus 1 and multiply it out, you have x squared, you have an x, another x, and then last term times itself. Now, you could know the shortcut again, and this is we square things all the time. First term times itself, multiply these two together and double it, last term times itself. Okay, well the x squareds are on both sides, so I'm going to subtract x squareds from both sides. And now I'm going to go and subtract 2x. I get 2x is equal to 1, x equaling 1/2. And before I finish, I want to make sure that actually works okay. If I plug in 1/2, I'm not taking logs of negatives. So we can actually go through and actually kind of calculate it out. So the answer here is x equals 1/2. Okay, question 6. We want to know what is the degree of the polynomial. So I got to think about, if I multiplied this all the way out, what would it look like? Well, the -3 won't matter. I'm just looking at just the x's. So I have 2x times x squared times x to the 5th. My biggest term is going to equal 2x, I'm going to add my exponents like having a 1 here. So I have 2x to the 8th. Now I'd like to actually include the 2 because in higher courses we look at dominant terms, and that's actually what the dominant term is. We look at the highest power, which also tells you about the degree. My degree is that highest power, which this case is 8. Okay, we're going to find the vertex, and there's 2 different methods we'll show. First method is completing the square. So I'm going to subtract 5. Then I need to factor out a 3. I'm going to leave a little space. Now, I take half of this and square it. I'm going to add that in here. So I'm going to add plus 1. Now when I added plus 1, I actually added 1 times 3. So I'm going to add 3 on the other side. So this gives me y minus 2 is equal to 3x plus 1 squared. Just like when we squared the other ones, kind of recognizing that form. Then y is equal to 3x plus 1 squared plus 2. My vertex, we do the opposite for the x. Then we have the y. So I know my answer is supposed to be B. Now, if you get stuck or you have trouble with completing the square, you can do it another way, and that's using the idea of the y-intercept. I'm going to let this equation equal 5. So I'll do 5 equals 3x squared plus 6x plus 5. Then if I subtract 5 from both sides, I get 0 equals 3x squared plus 6x. I'm going to factor out 3x. When I solve this, I get x equals 0 and x equals negative 2. Your vertex is halfway between it. So halfway between 0 and negative 2 is negative 1. Then I'm going to take negative 1 and plug it back into the original equation. So 3 times negative 1 squared plus 6 times negative 1 plus 5. Negative 1 squared is 1 times 3. 6 times negative 1 is negative 6 plus 5. Get negative 3 plus 5 is 2. Got the same answer. Okay, problem number 8. Another log problem. So I'm going to have to get the log by itself to be able to undo it. So I'm going to, first step I'm going to do is I'm going to subtract 3. So 2 log base 3 of 1 minus 2x is equal to 4. Log base 3 of 1 minus 2x is equal to, divide both sides by 2. Okay, now I'm going to try to solve this. So I'm going to change from log form to exponent form. My base is 3, logs equal exponents, there's my exponent. So I've got 3 squared equals 1 minus 2x. So I have 9 equals 1 minus 2x. We will move this up here. So I'm going to subtract 1 from both sides. I have 8 equals negative 2x. I get negative 4 is equal to x. And I get nervous because I see a negative dealing with logs. I want to make sure if I plug in negative 4, I don't take logs of negatives. So I get 1 minus 2 times negative 4. So that's 1 plus 8, that's 9. Log base 3 of 9 is 2. So I have 2 times 2 is 4, plus 3 is 7. It actually works. So it's a good idea to always check your answer afterwards. But that one is okay. So you got to be careful. You always want to check logs to make sure that in the process of solving you don't get a negative answer which you have to throw out. Okay, this will be the last one for this particular video. And then we'll have another video in a little bit. Okay, so I'm going to solve where these two intersect. I'm trying to find the values of x where this is going to occur. Well, they're both y equal, so I'm going to set them equal to each other. So I've got 2x minus 5. And then I'm going to square this right here. So I'm going to use that shortcut again. It's x squared. I multiply these two together. I get negative 2x, and I double it, is negative 4x. Last term times itself is positive 4. And then I have my minus 4. So we have the 4 minus 4. Those are going to cancel each other out. So I got 2x minus 5 equals x squared minus 4x. Okay, so I have a square, so I'm going to move everything to one side. So subtract 2x, add 5. This factors to x minus 5 and x minus 1. So I get x equals 5 and x equals 1. So it'll be A and D.